I'm Harris, and I represent Predictive Analytics. Let me briefly introduce Predictive Analytics. We are a silver partner with IBM, who have taken on this initiative to build the Watson skills among all academicians. Predictive Analytics is also the same company which have been behind popularizing SPSS between all academicians in the past. Since this is our first initial engagement with you on watsonx, we'll be sharing a feedback form at the end of the event to understand your interest levels on the product. We'll be happy to continue our engagement with you based on your feedback. Ahead of this event, like I mentioned, we have a program that we have devised that we will engage one-on-one to empower all academicians with the potential of Watson in education excellence, right? So we will be sharing the feedback form where you can fill in the information, say that how you would like to engage with us. We'll be carrying on a hands-on training against this event. We'll be carrying on a hands-on training on watsonx in your individual regions. If you're interested to such a program, attend such a program, you can mention it as part of your feedback form. We will also be sharing an e-certificate to all attendees against the feedback form that has been submitted. It's unfortunate that Ms. Lata Pai could not join us today. She is having, because of some health issues. However, I'd like to introduce Mr. Atul Joshi, who's also a client technical specialist with data AI team of IBM India. And he will be spending time with us, the next 90 minutes with us, helping us understand about generative AI, watsonx, and few of its applications. Maybe we will end the session with a question-answer session where we try to address as many queries that we get, assuming there's going to be a large group of attendees. We may not be able to answer all questions, but we'd be happy to answer one-on-one. If you can just mail us with your queries if your question remains unanswered, and we will talk to you or we will address it one-on-one, right? So I will let Atul take over from here, and he will be spending time with us explaining about generative AI and watsonx and its applications. Atul, if you can continue.
Hey, thanks, Harris, and good afternoon, everybody, and really thanks for joining and giving us the opportunity to walk you through some of the latest offering we have, especially generative AI being the buzzword these days. This is I trust that you would really would like the conversation that we have, and there will be something that you can take back. So a brief introduction of mine. My name is Atul Joshi, and I'm part of IBM as a senior solution specialist. And my focus area is around the analytics within the plethora of offerings that we have. And nowadays, especially with the generative AI being the flavor of the season, that is something that I focus as a specialty within IBM for me. So let's dive into the discussion about what all things that we are talking about these days when we talk about large language models and foundation models and generative pre-trained models and stuff like that. So I'll walk you through that, and we'll also talk about how watsonx can really be of help, not only to the large businesses but also to a lot of enthusiasts, people in academia, with the huge amount of research that we are doing, around this area as well. So as you might have noticed, experienced, worked on different aspects of evolution that has happened, and we had seen, the whole thing initially started with very rudimentary sort of rules engine. In fact, we talk about AI, and if you look at some of the history of AI, there were some smart bots, smart assistants developed even in early 60s. Those were the days when even computers were kind of new, and then it kind of evolved with more and more progress around the whole ecosystem of not just hardware, software, but the new abstraction layer of how you can use some of these fantastic technologies. And then we really saw the advent of this in the last decade with a lot of huge amount of data being available to us in a form of streaming device, in a form of social content, and people really looked at how do you actually start analyzing that data, getting the value out of it. That gave rise to the AI ML sort of spree in this whole arena. And again, I mean, with that, we what we saw was very dedicated, purpose-built AI applications that were available. And in last, I think around 5 to 6 years, there is this new emerging trend that we witnessed, especially in the last 1.5 year or so, with the advent of ChatGPT. I'm sure you must have heard about that and probably experienced some of that stuff as well. And we'll also talk about how the things are evolving. What as a AI practitioner you could be looking at in terms of moving beyond a single specific set of technology or a framework, right? So let me just again take a step back and just let's walk through a brief schematic on how these large language models or foundation models really work, right? So essentially, at a very high level, we see that there could be different specific tasks that the AI ML models can be built to use for. So it could be a specific task around, let's say, something around the natural language understanding, natural language processing. And if you really translate that into a use case, it can be a Q&A session, it can be a summarization, it can be extraction of some key fact entities. It could even be the translation, where you probably would look at how these neural networks try to kind of mimic that. But again, at the end of the day, these are all specific applications. So they are very good at performing a specific type of task. And then with the foundation model, and we often talk about the GPTs. So it really is the G, which is the generative, and the P, which is the pre-trained aspect of these models. So what really happens is you can probably associate that with a smart student. So we have a lot of students and academia people here as well. So let's consider that this is a guy who is very quick to learn, and he knows many things. And you must have heard about the zero shot and few shot learning, right? So there are few things that he already knows, and given a brief amount of training, he can do wonders even with the multiple tasks. So that's like a similarity if you have to put it into the real world aspect of it. Now what happens is this actually these kind of architectural choices can actually help you work across a plethora of use cases, not just single use case that you can talk about. So the same set of model when trained, you can use it for multiple areas. For example, translation, summarization, extraction of key facts, question answers, etc. Now, if you look at the traditional models, and I'm sure you must have heard about the supervised learning, where we need to provide a lot of input, kind of train these models with the human input, and then it will possibly learn from those aspects, right? So there's a lot of work. It takes a lot of energy. Again, these models sometimes deteriorate in terms of quality as the time passes by. So you have to always do a recalibration of the same, right? So those are some of the challenges. Now, if you compare that with these large language model, what really it is a huge a kind of evolution of the next word prediction. So I'm sure you must remember even a few years back we started having those chat applications and started typing on our phones. We had actually witnessed some sort of intelligence where it kind of predicts the next word. So it was like a mini aspect around that. But with these large language models, what really happens is this prediction of the next context happens at a very massive level, right? So now we are not talking about a word. We could be talking about sentence, paragraphs, and a whole content around that. So it has a large span of attention. And just to give you some context to that, and some of you who have worked on various models, um, uh, we have something called RNN, recurrent neural network, which was very good. Um, However, one of the challenge was the attention. So you start training that model, and with specific attention span, it can give you the right output. But if you give a lot of data, then it probably may not be able to remember what was said, some time back. So it's like in case of human, let's say if we meet today face to face or over a phone, a couple of days down the week, we again kind of bump into each other. We should be able to recall, at least briefly, how our conversation was. So that's a kind of attention span we can compare. But this was one of the hurdles we had, and then we had seen the evolution happening in terms of this paper that was written, um, which talked about how to expand this attention, and this was with a new architecture called transformer architecture, right? So there are multiple technical aspects to that. We'll not get much into it. I'm sure a lot of you have already gone through it and probably are also aware of what really that is. But the point that I'm trying to stress here is these new architectural choices actually make it possible to look at a large data set, ingest that data set, get themselves trained, and hence the power of prediction, power of generating the new content becomes immensely possible for across the various use cases. So uh, in case of the traditional model, you can see that you would really need millions and billions of sentences for it to train, whereas with these kind of models, you actually provide a smaller set of training, but then it on its own, goes through a huge amount of training on a massive amount of data, and then it, gets sort of that knowledge that we talk about, right? And hence, what really happens is, so there is this phrase about, when we have a heavy rain, it's raining cats and dogs. So if you have to train the model, it looks at various options you have. Let me just go back, right? So whether it is training cats and dogs or whatever it is, and then you actually start predicting massive amounts of words, massive amounts of paragraphs and content, and it starts generating that output for you. So essentially, when you ask the question, it's able to retain the context and give you the right answer to your questions, whether it is a type of question which is just you know a simple Q&A, or it's a classification or an extraction of some other content, right? So what really happens is you can start with a finite amount of training, but there is always a way to, again, give it a better push. In the technical terminology, it is called fine tuning, which means that, you really get into more detailed training aspect of these models and ensure that the quality of the output is better. Again, there are aspects around how do you actually train these models with the fine tuning capability, because as you might have seen, as you might have heard about it, right? Training these models requires a huge amount of GPUs, right? So it's really a huge compute that we are talking about, and again, quite a massive uh, set of data that you would use. So how to do that, right? So that's a kind of question that we talk about, and there are ways to look at the complete fine tuning, or look at a simplistic prompt engineering, which is working with a smart way of asking a question so that you get the right answer, and there is also a middle path as well, right? So what can happen is, with fine tuning, you have the best of the option, best of the output that you can generate. and then you have the same model which caters to multiple types of use cases, and you can use the same model now that is generating the content for you, right? And often we hear about this confusion between foundation models and large language models and LLMs and pre-trained generative models. So what are these differentiations essentially? So what happens is you know there could be some models which really need to generate stuff. So we call it decoder models, where it looks at the amount of training you have and then generates an output for you. There could be some simpler use cases. For example, you might need some things where you are primarily focusing on the classification aspect, or it could be mix of both, right? Again, in terms of data, it could be the text. So essentially, you must have heard about putting the entire internet content onto this model to learn. At the same time, you must have also heard about the evolution that has happened in terms of image generation, right? So images, videos, geospatial data, or protein structures. So these are the actual different types of foundational models. Essentially, follow a similar architecture of massive attention mechanism with large amount of data being trained on a transformer architecture, right? And what we have done for this is, and you must be remembering this phrase, right? Garbage in, garbage out. So if you train the model with not so good amount of data, obviously there will be challenges in terms of kind of quality that it throws out. And you must have heard about the initial, news around these models acting fancy, not using a very parliamentary languages, and some chatbot learning on the Twitter data and Reddit data and so on and so forth. So it really becomes important that the kind of quality of the data that you use really gives you a benefit in terms of its usage. So what we have done in terms of IBM is when we have this thought process of launching these uh, generative model capability, we have used uh, a validated data that is not just of good quality. So basically, there are two aspects around that, right? So you just take the commonly available data and then filter it out and take it. But what we have done is we have actually ensured that there are no copyrighted material. It's all legally validated. There are no HAP content, and then we've started with a huge amount of data culled down and used only a qualitative data for training our models. So that's about how do you train that data and get started using this data for these models. And that kind of brings us back to the evolution. So we looked at how we started with the simpler systems, and now we have arrived at a stage where we are even talking about we're not sure of where we'll be next couple of years, at the kind of speed of advancement that we are witnessing, right? Now, if you remember earlier, I talked about even bringing the even improving the quality of these large language models or foundation models. Although they are pre-trained, you can always look at a specific use case to train it better. And there are two approaches to it, right? So one of the approaches, and you must have heard about the jobs being available on the prompt engineering part of it. So prompt engineering, unlike many people think that it's a very technical thing. It is actually something that doesn't require too much of technical skills. It's about how do you guide a model to give you a better output. So sort of playing around with what kind of questions you can ask, and there are a lot of examples, in terms of asking the question in a right way. For example, you can ask the model to play a role of, let's say, an IT architect, and you can set out the rules for it. And then when you get the quality of the output, that actually talks a very technical language. Similarly, you can say, ask the model to play a role of a marketing specialist and so on and so forth. So It's all about, how do you ask the right questions, give a very clear step-by-step guidance so that the model would actually go back and, give you the answer in the right way. So that's about the prompt engineering. The extreme other aspect of it is the fine tuning, which means that you go back to the basic, provide more training to the model, and ensure that the quality of output goes up. You probably are talking about huge amount of human resources, probably some really experts, maths, CS, PhD kind of skills to really fine tune the model to justify the cost of training. And here we are not just talking about people working on PC. There is also a huge amount of hardware cost because it needs massive amount of GPU processing to really run those large number of parallel jobs. Now, what is also emerging is a midway through that, right? So what we have is something called PEFT, or parameter efficient fine tuning, and there are multiple ways to do that. But just to put it very simple, what it does is, if you might have heard about, when you improve the quality of the model, what really happens is the weights which are assigned to the model actually change. Right now, I'm sure you must have heard about human brains and comparison of that with the number of parameters that these large language models have. So it really becomes difficult to change all the billions of weights, across the parameters. So for a given use case, what can happen is these weights are changed partially, right? So let's say, for example, if I ask a question around a specific area in manufacturing, right? Now, because the model is trained on a huge amount of data, it also knows French poetry, correct? So are you really looking at even changing the weights so that the linguistic skills will improve? Probably the answer is no. In fact, that is one of the reasons we'll also take you through our view of rolling out these large language models, how it is different from let's say someone like Google or ChatGPT, who have a monolithic model, right? So sort of one size fits all. How that differs. So with parameter efficient fine tuning, what happens? You have the option to specifically change the weights partially, and that way you are saving on the compute. You are improving the quality. It may not be as good as the fine tuning, but it would be X times better than just working at the prompt layer, right? And in our offering, we have kind of enabled these capabilities as well. We'll talk about that in the forthcoming slides, right? So if you kind of compare that with the traditional models, being very proficient in taking care of some of the individual aspects, a foundation model probably has the ability to cater to multiple tasks. Now, with this base understanding, what we have done is we have created an architecture where you have a robust architecture on which the foundation model can be based upon. So one way is using a proprietary model. For example, although you use ChatGPT, you can't go and change the weights of the ChatGPT model, right? Because that's all proprietary. They're not sharing how this is, how these weights are. At the same time, there is a huge, ecosystem of open source developers who have released a lot of open source large language models. They may not be hundreds and billions of, huge parameter models, but there may be smaller models, right? So, for example, 7 billion, and 13 billion, and 70 billion, and so on and so forth, right? So, what we have done is we have provided a robust architecture, so which really starts with an enabler foundation of modern architecture. Let's say a Red Hat architecture, which has the Kubernetes microservices architecture, on which you can use the foundation models, the required data, the consumption of the data. So this really becomes a place for you to address all the aspects, right? And then what we have is also not just the IBM models. So here you can see when we talk about the choice of watsonx.ai offering for these large language models or foundation models which you can train, validate, and tune. You have a choice of some of the popular Hugging Face model as well as the IBM models, right? So if for some of you may not know, Hugging Face is a very popular repository of open source models and open source data sets, which people can leverage. And we have seen in a lot of cases, people actually use base these models and train these models, custom train these models to get the better quality output. One of the famous, quite popular model is Llama 2. So in our choice of models that you have, we have LAN, Llama 2, and Star Coder, and all those models available. Of course, we also have the IBM Granite and other models that we can use, that one can use, right? And this actually helps you because sometimes you might need to use multiple smaller models to fit a use case. So let's say one model maybe doing entity extraction, but at the same time you might need to use that data and create a code and query it on a database, which might be something like a star coder model, which is more popular around generating the programming codes, right? And then you also have the ability in the interface itself where you can do the prompt engineering, which is, as I said, it just giving a proper instruction to the model so that the output is better. Or it could be the midway path that we talked about, where you make some changes, some tune those prompts in a way that you get better outputs. Also, the full-fledged, fine tuning, where you completely probably change the weights with additional amount of data, etc. Right, and we are also open in terms of the possibility where people can actually bring in their own models as well, right? So we've seen in some organization and some institution they're actually working on their own sort of custom models that they want to bring in and kind of combine the different output across the model, right? Uh, so all the while we are talking about the modeling aspect of it, so having those large language models, but to really use those models, we see that a lot of time the challenges is around getting the answer on a trusted data. So you must have heard about a term called hallucination. So for some of you who might not know, I'll give you a very simple example around hallucination. Um, so let's say some of the models which are trained as on, let's say a particular date, if you ask them how many satellites Saturn has, right? So it will say probably X amount of satellites. And if you go back and check that on Google with the latest NASA update, you will see that, there was some news recently. So the number of satellites that the Saturn has is actually a lot more than that. Now, what happens is while we say that the model hallucinate, it's really about whether the model is able to get the context that it needs to answer this question based on its own knowledge, or it needs to go back to a trusted source of data, right? So a lot of time what happens is, especially in the enterprise level, is the question that you are asking, the data is not there with the model because that's your own proprietary data, right? Your own terminologies that you use or your own transactional data, analytical data that you have. At the same time, you want to use this immense power of large language model to generate a content or to give you a classification or help you in your AI ML journey. So what we recommend is something called RAGs architecture. RAGs is retrieval augmented generation. So basically, if you look at the definition of that, what it does is it helps you generate, but generation is based on the retrieval of a trusted corpus, right? So we separate out the two things. So what we do is we essentially use a mechanism where we guide the model to provide an instruction that now it needs to go back to the source get the relevant data, process that in a natural language form, and then give me the answer. So that way, we are not worried about whether the model will learn from my data, because it is only inferencing, right? To some extent. So that's one of the way of and this is one of the architecture a lot of people we have seen following, especially when it comes to trusted source of data, RAG architecture. And then you also see that at the end of the day, what kind of modeling that you use, what kind of data that you use, how you are looking at the whole journey of putting the AI, putting the generative AI projects in your organization, in your institutions, has a lot to do with the governance, right? So it's not the machines and the architectures which are responsible for the output. It is actually the people. So what we have done is we've included the governance aspect, where people can look at how this whole model was trained on, what kind of data was used. When you actually are in the process of training the data, it also generates model card, in terms of checking the effectiveness of model across various parameters, socio-economic impact of that, the technical and statistical relevance of that. And also, over a period of time, when the model deteriorates, let's say in terms of quality, accuracy, bias might creep in, it kind of alerts, notifies, and keeps people on the track, right? So it has an explainability, it has a transparency, it has a collaboration that one can leverage. So that's the key aspect of governance that we have seen. And if you might have heard about some of the news recently, a lot of governments are talking about the importance of governance in these kind of projects, right? So that becomes really important. So in a way, what you do is you can use this solution, and in fact, when I'll show you the demo, you can also see that there is a trial version that is available. You can look at and do hands-on, and get a flavor of how this whole thing's work. But essentially, what we have done is we've made the whole capability of this solution quite flexible around the ecosystem, right? So you have the data aspect, you have the deployment aspect. So today we have this as a SaaS offering, but we also have an option there for some of the institutes. We can have a on-premise offering as well, right? Or on a cloud of their choice, public cloud of their choice. Right. So, and then what we have also seen is a lot of our other standalone products, we are infusing this power of large language models or generative AI capability. And you will see this pattern emerging, right? A lot of products would have, some form of, built-in capability around that. So that's the emerging pattern we've kind of started. Additionally, when we say, we always keep saying that large language models, but it's really a kind of subset of this. And we have our research team who has worked with one of the manufacturing players. So what they have done is they have created even a custom transformer model, right, specifically to create a digital twin of one of their manufacturing assets. So what happens is if you have to take a decision of setting up a new plant somewhere, they can actually run this massive amount of scenarios in terms of operational, financial aspect, feasibility of manufacturing, quality, etc., on this digital twin, and then they can take the decision based on the output of those. So a lot of innovations happening even beyond the LLMs within the foundation model area as well, right? Now let's look at some of the simple things that you can start with, and I'm sure once you have the hands-on experience of the solution, you will actually think about what use cases that you can pick up even to improve your productivity, right? It can be as simple as creating an email that you want to write it to somebody, or quickly take some sample data set that you might need in a work in terms of some random or synthetic data sets that you want to generate, or let's say what kind of people, organizations, actions are being talked about in a content, or just ask a question to the PDF itself, right, on the large amount of unstructured data. So while these look like, 5 use cases, if you really drill down into various business areas or various productivity areas, even for students, academicians, and all of them, this really can be a big, thing to look at. So with this, what I'll do is I'll cover a brief demo of the product. So let me stop sharing the deck and I'll start sharing my browser. Right. So as you can see, what we have is the entire AI studio that you can start working with. So when you really go to the welcome page, of course you have the LLM prompt studio that you can work with, but at the same time we are not forgetting the traditional AI ML use cases, right? So you have your Python R code which you want to use and deploy. All of that is possible. In fact, what we are seeing is in a lot of use cases, it's actually taking the productivity of these traditional models to the next level using the foundation models, right? So let's look at the prompt studio. So prompt studio, as I said, this is not really technical. It's about using a model and starting to create some content or doing some classification, etc. And for that, what we have done is we have provided some sample examples here. So as you might have seen earlier, right? So you have summarization, classification, generation, Q&A. So we have some samples which you can tweak and make changes to suit your data sets. So for example, let's say if I click on meeting transcript summary, what I can do is I can start giving the instruction. So for example, I have some data sets about some conversation that has happened in a meeting and I want to summarize that. So I'll start with few examples here. So this is something what we call a few short learning. So I have a couple of examples. I can go on adding more examples, and when I want to test this for a given data set, what I need to do is I need to click on this button called generate, and then it will generate the summarized output for me, right? So as you can see, it has the summary available here. If I'm happy with this summary, I can also click on this icon and promote that as as additional example. So as I work more on these use cases, this will definitely give me a better result. Now let's look at how this actually was created. If you notice, earlier we talked about a choice of model that we have. So here you can actually select which model you want to use, right? And then it also comes with a detail about this model. We call it model cards. So for example, uh, there are some IBM models like Granite, and there are some models which are open source. For example, Llama 2 is an open source model, or a star coder, and so on and so forth. What you can do is you can actually look at one of the model and see how this model was, really created, right? So there are these detailed model cards available in terms of what kind of data sets it was used, how it was trained, what are the various factors, metrics around that. And you also have a complete detail around that. So for example, if you go into the, drill down into the details, you will get a complete paper of, how the Granite model was created. So this is available. So for some of you who are into research and deep into academia, they can really look at what are the nuts and bolts, how the model was trained, what kind of data set that we had used, how this it was ensured to bring in the quality into the model, etc., etc., right? So a lot of details are available, and these details are available for all the models you can use. So that actually helps you make a choice about which model is going to be used, right? So coming back to our prompt, now the other thing is, if you look at various parameters that are available to tweak the model, these parameters are available for you as well, right? So what you can do is, while you look at this sample, you can say that I want this model to give me the most optimized result, right? So there could be a couple of options. For example, greedy option actually gives you the best optimum scenario, right? So in this particular case, we have a greedy option. But if we take another sample, so for example, let me select something else. So let's say something like marketing image generation. Now here you don't want just optimization. What you really want is the ability to make changes or tweak few things. So you can change the temperature. If you are looking at some of the other decoder parameters like top P and top K to improve the sort of creativity, or sticking to just the base guidance, you can do that. There is also thing about the reproducibility of the question. So you can put a random seed around that, right? And then obviously when I created that, generated that output, I also get a reason that, how many input tokens were used, how many output tokens were there, for a given sort of scenario, right? So this actually gives you a complete flexibility. And then you have some zero shot learnings as well. So for example, a built-in sentiment analytics. So here we are not giving any example. We are just taking a given prompt and asking it to generate. So when I say generate, it actually quickly creates a classification for me, right? So what happens with this? You can select any of these, and if you really want a free form, what you can also do is you also have this free form example here, right? So here you can actually type it, the way you want, and you can provide those questions. So for example, if you're looking at a question from an article, and if I switch to a free form, I can actually ask these instructions, give a detail about the article that I'm going to ask the question on, give some samples around Q&A, and then start generating this content. So this is available for me as well. Now, additionally, what I can do is, so let's say I have this prompt which I have for the sentiment classification. I can save that. So I can just simply save this as a prompt template or a prompt station, or I can also create a notebook, right? So let's say this is called sentiment analytics notebook, right? So I'll save this, right? So now what happens is, since everything is within these different projects that I have, I'll go to my project, which is test project 11, and within that I have this asset which is created. So in this asset I have the prompt templates. Sorry, I have the Jupyter notebooks which is automatically created for you. You can use this, you can download this, and work around that. You can programmatically control a lot of things. Use it as a web application that you will deploy. So this gives you a lot of flexibility to work around if you are especially into developing these kind of things, right? Now what we have also done is we also have a repository of GitHub around some of these assets, right? So you can visit these repositories, see how the things are created there, and maybe tweak a bit here, right? Now what we have seen is the prompt studio. We also saw that we have the ability to create a notebook and then deploy that. Let me show you some samples around how these things are being created by our AI engineers and also our partners who are working across multiple institutes and the and companies. So we have something called IBM Digital Self-Service Co-Create Experience, and this comes with a lot of pre-built assets to play around with. For example, let's say we select this particular use case, and you can actually select the use case based on the various categories. So for example, what kind of task you are using, what kind of model you are using for this, right? And if there is any complementary product, you can use that as well. So let's look at one of these newly available use case for scan document. Now here what we are doing is we are taking a PDF or unstructured data and trying to understand the details about that, right? So let me go into the demo of this, right? let's say we select a bank statement, right? Now, what we have here is, a simple extraction, using, let's say, open source stuff. But let's look at, how the output is generated for a given question. So if I say what is the closing balance and ask this question, you can actually compare that, the, finer differences. So for example, here we just, extracted the amount, whereas you also have the currency here, right? Now, I don't know how visible this is, but in this PDF, there is a special number for the people with the hearing impaired, right? So that is something additionally available here, right? Um, so what I want to ask is how people with disability can contact customer service, right? Now, this is actually a bill and or a bank statement, right? And in the traditional scenario, what you have is the ability where you have these details, but then um, with the foundation model that you have chosen, this actually gives you a very specific thing around, what is being asked for, right? So here, for example, you have these details about the, uh, specific numbers that are available for the hearing impaired and so on and so forth, right? So this is one example. Let me show you another example as well. Right. So let's say a simple example. Right. So I have some sample conversation here, or I can also use a file that I want here, and I can say get insight, and then it runs the foundation model or large language model in the background to generate the content for us, right? And what it has done is it has created a sentiment uh, output in terms of sentiment, and also given you the key entities around that. Now, you also have an option to see how this has happened. So I have this setting button here. I can click on view payload, and then it tells me, what are the various things I've used. So here you can see in the earlier prompt studio, we had all those details, right? So for this particular use case, I'm using the MPT7B instruct2 model, and these are the decoding parameters that I've used. So this was for the summarization use case. Then we had used something else for the sentiment, and then we have used something else for the key entity, right? So we are actually combining multiple models and packaging that in a given use case, where sometimes you see that one particular model works better for one particular specific type of use case. So that way you don't need to look at only a single model. You can use a plethora of choices of the model that you have and do the things, right? Now, for some of those use cases, let me see if I have here. So, for example, if some of you are interested, you can look at how the coding sample look like. So, if you click on this, you will be taken to the GitHub repository where you could look at how this model was created. There is a complete instruction that is available. You can create a copy and tweak it to your own requirements, right? So what we saw was, multiple things. We had seen an overview of, what really these models are. We had also seen a quick demo of, how you can use the prompt studio to quickly get, answer to your questions. And we had also seen that you have actually the ability where you can not only use the foundation model, but also use the traditional AI ML models, combine the two things as well, right? And if you want to do some hands-on, if you want to try out few things on your own, you can use a GitHub repository. We also have some different assets that are available across the multiple use cases, right? Which you can have a look at. So a lot of choices are there for you if you want to try that out. And this was a brief demo that I wanted to include. Let me just stop sharing and go back. Right. So I think I'm almost nearing my presentation. I'll just spend a couple of minutes on some of the things that I wanted to talk about. How do you really make the most of watsonx offering? Essentially, what happens is, um, along with the model, you also get the capability to have the governance in place, where you can have a complete white box approach, right? So unlike it just being a typical black box approach that one use, you can actually set the responsibility to the right set of individual, be transparent, have the workflow involved, look at the quality of data that is being used. You have the option to, really get into details about why a particular model was used. Was that really good for a given use case, etc. And then looking at the model cards and fact sheets, you have a complete transparency around that. The other thing is, sometimes the biggest challenge is also to train the data, train the model on the data set that you have. And these data sets, managing these data sets themselves are kind of projects. So we also have an offering where you could use watsonx data, which is built on a very open architecture. You can use Iceberg, Presto engines, Spark, and so on and so forth, to really, make the best of, our offerings, which will give you a qualitative data that can be used in the foundation models, large language models kind of projects. So with this, uh, this is more or less what I wanted to, have a conversation with you. Just to summarize, we saw the evolution of how we started from the rule-based engine, the big data, the AIML, and the today's world of generative pre-trained models. We also looked at the architectural choices, where you would have a choice of just using a single monolithic model vis-a-vis the ability to use smaller models which can best fit your use cases, right? So one of the examples that I give is, um, for your use case, do you really need your model to know the French poetry on a lighter note? And then the way of using these models, you can start with a simple GUI based, sort of approach, uh, and also for those who are from a developer background, they can really make use of the APIs which are available. They can use these models to ingest in the different applications, and then to really encompass everything, you have the option to choose the dot data offering as well as the dot governance offering, right? So with this, let me take a pause, and if you have any questions, we can open the forum